Good morning, students. Now we are having the continuation of our queuing theory, what we discussed earlier. So we have already discussed what is the queuing system and the service system. So here we have the configuration of service system. So already we have seen in the earlier video that there will be number of parallel service channels. So the customers will entry into the service system depend on the queuing condition. If at the time of customer arrival, if the server is idle, then the customer is served immediately. Otherwise, the customer will be asked to join the queue, which can have several configurations. By configuration of the service system, we mean how the service facilities will exist. The service systems are usually classified in terms of their number of channels or the number of servers. So here the customer is arriving, so the queue is there. So this is the service facility. So the customer will get the service and he is leaving the system. Now we'll see, depending on the number of service channels and number of servers, how the service system is configured. So here we have the service having a parallel servers, but the single queue. So here the customer is arriving, so the queue is moving here. Then at this point, so the customers are divided into number of servers. So each customer, after getting his service, so he is leaving the system. So customers are served here parallelly. So if this particular server is busy and if this server is idle, so the next customer will be allowed to get service here. So this is the case of uh, parallel servers. Then we'll have here service facilities in series. So customer will enter the first station and gets a portion of the service here in the first service station. Sorry, and then moves on to the next station and so on. So that is the service facilities are in series now. This is the first service station, only the partial service is done. So then the queue continues and the next part of the service is getting done here. Similarly, so the series continues. So once he arrives at the last server, he is getting service there, then he leaves the system. Then several servers, several queues. So here, so there are several servers and several queues here. So whichever the length of the queue is less, so the customer is going to join that particular line. So there are several servers and several queues here. Now, coming to the numerical problem here. So, a self-service store is employing one cashier at its counter. So, 9 customers arrive on an average of 5 minutes, while the cashier can serve 10 customers in 5 minutes. Assuming the Poisson's distribution for arrival rate and exponential distribution for service rate, you are asked to find the average number of customers in the system, average number of customers in the queue, then the average time a customer waits before he getting a service, and the average time a customer spends in the entire system, that is both standing in the queue and getting service and then leave the system. So average number of customers in the system, those who are waiting as well as those who are in the servicing line. So then the average number of customers in the queue, that is who are standing in the queue alone. Then the average time a customer waits before he getting service. That is before he is coming to the service counter, how much time a customer on average spends. and the average time a customer spends in the system, both waiting time as well as service served time. Now, assuming Poisson's distribution for arrival rate and exponential distribution for service rate. So, these are the two distributions we are following. For arrival rate, Poisson distribution; for service rate, exponential distribution. So, we'll have the model with the arrival rate lambda. So that is 9 customers arrive per 5 minutes. So that is what given here. 9 customers arrive in an average of 5 minutes. So it is 9 by 5. So that is 1.8 customer per minute. So for 5 minutes 9 customer, for 1 minute it is 1.8 customer per minute. So the service rate. So it is given that the cashier can serve 10 customers in 5 minutes. So 10 customers in 5 minutes. So 10 divided by 5. So that is 2 customers will be served per minute. So service rate is 2 customers per minute. So now taking the performance measures, the average number of customers in the queue. So the formula used is this lambda divided by mu minus lambda. So this is the formula we are using to calculate the average number of customers in the system. So lambda 1.8. So mu is 2. Lambda once again 1.8. So we are getting 9 customers. So that is the average number of customers if you take at a particular time, those who are waiting in the queue and those who are in the service counter, considering all the customers together. So there will be 9 customers in the entire system. Then the average number of customers who are waiting for their turn. So that is lambda square divided by mu into mu minus lambda. So that is lambda by mu. So that is 1.8 by 2. So then this lambda divided by mu minus lambda. So we are having here the answer as 8 customers. So there are totally 8 customers in the queue and we got 9 customers in the entire system. So what does that mean? 8 customers are waiting and 1 customer is at the service counter. So the average time a customer waits before being served. So that is given by this formula. So that is lambda by mu into, so that is 1 by mu minus lambda. So we want lambda by mu here. So that's why in the earlier formula we have taken that lambda by mu separately. So that's why 1.8 by 2 here divided by 1 divided by mu minus lambda. Substituting everything here. So we get 4.5 minutes. So that is a customer wait for his turn is 4.5 minutes. So that is the average time a customer waits before he gets his service. The average time a customer spends in the system. So that is given by 1 by mu minus lambda. So that is 5 minutes. So totally he is waiting in the queue for 4.5 minutes and 0.5 minutes for his service done. So totally it is 4.5 plus 0.5. So that is in the system he will wait for the time of 5 minutes. That is for his turn, he will wait for 4.5 minutes and at the service counter he spends 0.5 minutes. So totally it is 4.5 plus 0.5. So totally he spent 5 minutes in the system.